Hey everyone, welcome back to another video by Camroom 5. Previously we have been talking about the Hess law and we have talked about the Born-Haber cycle. We have done few examples also and we have defined various values that were new for us. In today's video we're going to be talking about another Hess cycle which is concerned about the solubility of the ionic substances. In one of the examples for the Hess cycle we came across the concept of the lattice energy. And we defined lattice energy of a substance as the energy when the gaseous ions, for example sodium gaseous ion, would combine with the chloride gaseous ion to make solid sodium chloride lattice. And that was the lattice enthalpy for none other than the sodium chloride. But now imagine if you are adding excess water to this ionic lattice and you're trying to dissolve it. Even that has some energy changes associated with it. So let's make another arrow, not black, let's pick some other color. I'm not being racist, I'm just being specific here. So red arrow, not black. And let's suppose when we dissolve excess water, the ions dissolve in water and now the state symbol becomes aqueous for both of them. We will call this the enthalpy for solution for sodium chloride. It's a new word for us, so it would be good if we define it also. So let's talk about enthalpy for solution, which is, it is the energy change. Obviously we are concerned about the energetics, so it's the energy change when 1 mole of ionic lattice dissolves in excess water to make a solution at standard conditions. STD, I know what you're thinking, it is standard conditions. It's the energy change when 1 mole of ionic lattice dissolves in excess water, make a solution at standard conditions. These are two steps which are connected with each other, so you can see, let's make a highlight. These are two steps which are connected with each other, so you make a lattice from the gaseous state and then you make a solution by dissolving it. You know what would be the direct step of these two things? It would be if you directly made the ionic solution from the gaseous state. So if you dissolve the gaseous ions directly, that would be something we call hydration of the ions. It would be known as the enthalpy of hydration, and enthalpy of hydration is not for combined sodium chloride, it's for individual ions. So it would be called enthalpy for hydration sodium ions plus enthalpy hydration for chloride ions. Let's define enthalpy hydration also. Enthalpy for hydration, it is the energy change. It is the energy change when 1 mole gaseous ions dissolve in excess water to make a solution at standard conditions. Again, notice one thing, that it's not about the entire lattice, it's about 1 mole gaseous ions. It is the energy change. You're dissolving them in excess water at standard conditions. In this way, our equation becomes the direct step plus the indirect step. So there's a direct step which was the hydration and there was this indirect step. So indirect steps are I'm highlighting with blue and there's a direct step which I'm highlighting with green like in the arrows. The direct steps were hydration of sodium ions and the hydration of chloride ions. They were together equal to the formation of lattice, so lattice energy for sodium chloride, and then dissolving this lattice, so the solution of sodium chloride. This is the equation that we'll use. Let's do some past paper questions to create a better understanding of it. The first question is define the term lattice energy. So we know that the keywords are going to be energy change when 1 mole of solid ionic lattice is made by its gaseous ions at standard conditions. So you're making 1 mole of a gaseous, you're converting 1 mole gaseous ions to make the 1 mole ionic lattice at standard conditions. Let's continue. It says use the following data to calculate the value for the enthalpy change of solution. So they want me to calculate the enthalpy change for solution of copper to chloride. You might find it useful to construct an energy cycle. So let's first read these equations and let's see what they are trying to communicate. Enthalpy change of hydration of chloride. Remember what's hydration? Hydration is when the gaseous ion goes in water, so I'm putting H2O above the arrow, goes in water and makes aqueous ions. What is enthalpy change of hydration for copper 2+? So that's going to be copper 2+ ions were in the gaseous state. They also went in water and now they made aqueous copper 2+ ions. What is lattice? So lattice, we all know, lattice means copper 2+ ions were in the gaseous state and chloride ions were in the gaseous state. They made copper chloride, which is in the solid state. Notice one thing, we need CuCl2. So Cl2 can be obtained by double mole chloride. Let's make an energy cycle for it. I always put lattice on the horizontal axis, so it's easier for me that way. So copper ions were in the gaseous form, double chloride were also in the gaseous form, and they made copper chloride in the solid form. That is what I call lattice enthalpy. Then downward arrow can be obtained for solution where copper 2+ ions become aqueous and 2 moles of chloride ions become aqueous through solution because you dissolve them in water. I call this a series of direct steps. So I call it a series of, call it a series of indirect steps. What would be the direct step for me? So that would be if somehow I hydrated the gaseous ions directly. We call it hydration, right? Hydration means directly from gas to aqueous. It will be hydration enthalpy for copper 2+ and 2 times the hydration enthalpy for chloride. You know why 2 times? Because we are dealing with 2 mole chloride ions. What's our equation in this case? It becomes lattice enthalpy and solution enthalpy is equals to the hydration of copper and 2 times, not just 1, 2 times hydration of chloride. So let me put it here like this. Chloride hydration and copper 2+ hydration is equals to the solution and lattice. The lattice value has been given as minus 2824. Solution is missing. Hydration for copper is minus 378 and hydration for chloride is hydration of copper was minus 2099 and hydration for copper was minus 378. I'm pretty sure you can solve it mathematically and you can get the answer. Let's move to the other question and say, use the following data to calculate the lattice energy of calcium nitrate. You may find it useful to construct an energy cycle. We are doing it again for our practice, So horizontal axis is for lattice energy. Lattice energy means you get calcium ions, you get 2 mole nitrate ions because the formula involves them. You make 1 mole calcium nitrate in the solid form and the ions were in the gaseous forms. You call it the lattice enthalpy. Yeah. Let's move it. Okay, sorry. Yeah. Like this, yeah. Sorry. The solution enthalpy would mean that now the ions are in the aqueous state because you dissolved them in excess water. So calcium is aqueous and nitrates are aqueous. The direct step would have been called hydration. It would have meant you are hydrating the calcium ions and you are 2 times hydrating the nitrate ions. Why 2 times? Because the nitrates are involved for 2 moles in this formula. The lattice energy is missing for us, so it is X. The solution value has been given as minus 19 and hydration values are minus 1650 and 2 times minus 314 and 2 times minus 314. You know the formula that has already been given over here? That's lattice plus solution is equals to the hydration of calcium and 2 times the hydration for nitrate. You can solve it by putting in the values and you can get the answer. I hope these ideas are clear for you. In the next video, we'll talk something about the charge density. Stay tuned guys. Thanks.